guys, so let's do some algebra. So today, like Yolanda said, we are looking at like terms in algebra. So my first question to you is, and you can raise your hands at this point if you would like to, what are like terms? So what are they? How do I identify them? What do I look out for when I want like terms? Watobe, tell us. Watobe, you just need to unmute. Oh, there we go.
Ma'am, aren't like terms that are alike, terms like, ma'am, I don't know how to explain it.
Do you want to give an example? Okay, have a think. It's okay. Have a think. And then you can always add to it in the chat. But thank you for raising your hand and being brave enough to do that. Monde, do you want to help? Whoops.
Yeah, okay. Easy. Yeah. Like terms, no? Like terms have the same variables.
Good. Okay, so like terms are terms that have the same variables.
Well done, Monde.
Now I'm going to
Thank you.
terms that have, sure. So I'm going to add here and the same exponent. Okay, let me just, clearly my brain's not working tonight. I'm going to write it and then I'm going to say words. Okay, got there in the end, sure. Every now and then I can multitask, but every now and then I cannot multitask. Alrighty, so terms that have the same variables and exponents. Now we haven't done exponents yet. We're going to do exponents in term 2, but I want to put it there because it is important that we realize that exponents are also important when identifying like terms. So guys, as an example, if I gave you the term 2x cubed and let's say, for example, minus 4x cubed, because they have got the same variable, so because they both have an x, and because they have the same exponent, which means that both of the x's have an exponent of 3, they are then like terms. So these are like terms. If I gave you something like, I don't know, x squared and 2x, these are not like terms because even though they have the same variable, the exponents are different. I've got an exponent of 2 from my first term and an exponent of 1 in my second term. And so because those exponents are different, they are not like terms. So it's very, very important that we know what we're talking about when we've got like terms. Just another example so that you can see, for example, something like 3x and just the number 3 are also not like terms because we can clearly see here that from my second value, I'm missing an x. There's no variable there. So they can't be like terms because that one doesn't have an x. So like terms must have the same variable and the same exponent. Now, just as a quick reminder, terms in an algebraic expression are separated by plus and minus signs. And so it's very important that we can identify our terms in an expression because otherwise we're going to get quite confused about what is needing to be simplified. So terms are separated by a plus sign or a minus sign in expressions. Multiplication and division don't come into it, just plus or minus. So I'm going to stop here in case anyone wants to take a screenshot. I'm also going to stop if there's anyone who wants to ask me a question or clarify anything. But otherwise, we're going to have a look at some, English. We are going to have a look at some examples. Okay, so I'm just waiting in case you want to take a screenshot of that. Alrighty, grade 8. So let's have a look at some examples. We're going to start off nice and easy. We're not going to run before we can walk. So here, I'm actually going to leave off A for now. Well, we can come back to that. I just want you to ignore A. So let's call this question A, and let's call this question B for now. So if we have a look at question A, first thing that we always want to do is we want to identify the terms in our expression. Now remember, I've just told you that your terms are separated by a plus or minus sign. So there's a minus sign, there's a minus sign. They are separating our terms for us. So we've got 1 term, 2 terms, 3 terms. Those are my terms making up my expression here. So in this expression, I have got 3 terms. Once I've identified my terms, I always want to double check if I can simplify the terms. Now, sometimes this is already done for you, as is the case in question A. Sometimes you still need to do it. So sometimes, for example, you might have, let's say, for example, this was over 2, and then you could simplify that fraction. But in this case, there's no simplification that I need to do, so that's done for me. And only once all of my terms are as simple as they can be, do I go and add and subtract my like terms. Now, we obviously need to know what our like terms are. So whenever I'm doing algebra, I always like to have a highlighter or a colored pen or something with me so that I can highlight my like terms. So remember, like terms, they must have the same variable and the same exponent. Now, all of these terms have an x variable and an exponent of 1. So these are all like terms, which means that I can add and subtract them. Now, grade 8s, remember, when you are adding and subtracting, if you're struggling, remember to use a number line, all right? There's no shame in using an aid to help you get to where you need to be. Especially to start out, you will get more comfortable with this. So if we start here, we've got 6 x's. I'm taking away 2 x's, and I'm then taking away another x. So I end up with 3 x's as my final simplified answer. So what you need to take note of here is that it's only the coefficient that changes. It's only the number in front of the x that's going to change. The x stays x. The variable does not change. It is only the coefficient. Right, so I want you to try B for me. And I want you to remember, just like we had in question A, if there's a variable by itself, there is actually a coefficient of 1 there. So give B a try. I don't want any hands yet. Put your answers in the chat. And then in a minute or so, I will ask for some answers. Okay, keep those answers coming. Well done. Well done, grade 8s. Righty, would anyone like to raise their hand to tell me how they got? Ooh. I'm glad we're also excited to raise our hands. Didn't you there? Oh, we can't hear you, didn't select the correct audio option for the headphones. Okay, we'll figure that out.
Yeah, otherwise I can help you, Didintle, on if you can hear us, I'll send you a private message.
Okay, Chipo, do you want to help me with B?
Hello.
Hi, are you there?
Yes.
Okay, tell me what I do in B.
So I did 4. Can I say 4W? Is that fine?
Yeah, perfect.
Okay. So 4W plus 1W plus 1W will be 4 plus 1 plus 1, which should be 6W.
Excellent. So guys, what I like in that explanation is the way Chipo described the fact that you actually just add in the coefficients. So to get the 6, all I actually did was I said 4 plus 1 to give me 6. And that's what I said earlier. The coefficients or the number in front of the variable change. The variables never change. If it was W, it stays W. If it was X, it stays X. So just remember that as you go along. Right, so I'm going to take off my scribble here, and I want you to have a try of what is now our question C, but was our question A. So try C for me. Monde, I see your hand is up. Do you have a question? All right, guys, while you are trying question the new C, if you have any questions, now is the time to raise your hand while everyone's giving it a try. Monde? No? Okay. Wandle, do you have a question?
Yes, ma'am, I have a question. How are you, by
Yes.
the way?
I'm fine. How are you?
I'm fine. So, ma'am, I have a question. So, since you said 6x minus 2x minus x, right? So, what if the variables are different?
Okay, so we're going to do examples now where the variables are different, but that is where it becomes very important to identify our like terms.
Okay, ma'am, thank you.
Okay, good question. So guys, we are going to do ones where the variables are different. Reese, do you have a question?
Yes, ma'am.
Yes, what's your question?
Ma'am, may you please go back to the definitions?
I
I
will
wasn't
go
here
back.
yet. Okay,
I'll go
ma'am.
back there in a second, and then you can take screenshots.
Okay, ma'am.
All right, so, ma'am.
Thank you.
Sure. Alrighty, guys, hands up. Who would like to help me with this weird question C that I had going on here? Apalele, help me out with C.
Hi, ma'am.
Hi.
Ma'am. For C, I said I put 1 in front, or I put 1 in front of y minus y, 1y, which gave me 0y.
Okay, perfect. Now I want to discuss that. So guys, 1 minus 1 we know is 0. Whenever we subtract something from itself, we get 0. And so, yes, we have 0y. But what I want you to think about is the fact that this actually means 0 times y. But anything times 0 is 0. So actually, our final simplified answer here is just 0. If we have 0 and then a variable, we don't have to write the variable because anything times 0 is 0. And so we can just leave our answer as 0. All right, so what I'm going to do quickly is I'm just going to make that a touch smaller in case anyone wants to screenshot. Please remember to mute yourselves, guys. Otherwise, we're going to have chaos. So take your screenshots of the definitions and of the question. If anyone has any questions, now is the time to raise your hand before we have a look at our next example. Okay, Litesh.
Sorry, ma'am. When you said x minus y, then you need to find 1. Then you said 1x minus 1y.
You won't, but remember those are then not like terms because you've got an x and a y, so we wouldn't be able to subtract them.
Okay, ma'am.
So we would just say 1x minus 1y.
Okay.
Okay, good. So that sort of links with, I think it was Luande's question of what happens if our variables are different, but we're going to get to that. Right, guys, I hope we've all got our screenshots. Have a look at these next expressions for me. You guys are on a roll, so I want you to try these by yourselves. So in the chat, write A, B, and C with your answers. Remember, check and see where your like terms are and add your terms together. Be careful of the signs. A is y plus y. And guys, just a reminder, after you've raised your hand and asked or answered your question, please remember to mute yourself. Please also remember, grade 8s, that in our answers, unless it is 0, you should have a variable in your answer. Okay, so as everyone's doing, well done. Label those answers as they come through so we know which is which, but well done. So far, everyone's labeled their answers. We're learning. And Paul, just be careful there for B. There's no Y. So there shouldn't be a Y in your answer. Good, keep them coming. Oh, Lawrence, it's a lot of sixes. Righty, guys, would anyone like to raise their hand to help me out here? Right, Bonolo, help me with A.
Hi, ma'am,
Hi.
and hi, everyone.
Yeah.
The answer is 2y.
Perfect. Okay, so guys, remember we've got those imaginary, let's not call them imaginary, you've got those invisible or ghost ones in front of the y's. And so when we add them together, we've got 2y. So just be careful. This is different to what we did here. That was minus. This is now plus. So we do actually need to have a y there. Right, very nice. Well done. Oh, we've got so many hands. This is wonderful. Lawrence, help me with B.
Ma'am.
Hi.
Ma'am, for B, we're going to say 2x plus 3x, which is equals to 5x plus the 1x, which is equals to 6x.
Perfect. Well done. So guys, 6x here for question B. Very nice. Seatley, help me with C.
Hello, ma'am.
Hi.
Ma'am, for C it's 6W because ma'am, 4W plus W is equals to 4 plus 1 plus 1, which is to 6.
Excellent. Well done. Alrighty, guys. So those are your answers there. I know there's lots of hands, and like I say, I'm doing my absolute best to try and get to a new person each time. So will do my best not to repeat hands. But here we've got our answers for A, B, and C fully simplified. Right, so I want everyone to lower their hands. You're taking screenshots. Right, everyone's hands are lowered, perfect. If anyone has a question, now is the time to raise your hand. Because at least now I know it's you with question and not just a leftover hand. Right, Umpa? There you go.
Ma'am,
Yes.
I do not understand C.
Okay, so for C, we've got, oh, sorry, that was a weird noise. So in C, we're starting with 4 W's. I'm adding 1 W to get me to 5 W's, and then I'm adding another W to get me to 6 W's. So I'm just adding more and more W's to get more, and my final answer, 6W.
Yeah.
Okay, Apulele, question?
Ma'am, for A, ma'am, because the answer is 2y, ma'am. Don't you say 2y times 2y and then get 4, or you don't times it here?
So we're not timesing here. There's no multiplication that I need to deal with here, so we don't need to times.
Thank you.
Alrighty. Remember, mute yourselves, guys. Okay, before we take a brain break, let's take a brain break. Right, brain break. I just mostly want you to see my joke because I quite enjoyed this joke.
I hope they get it.
Alrighty, guys. So there's your brain break. Hopefully we are comfortable and confident with these by now because I do enjoy these. I'm going to make it a bit bigger once you all read my joke and either appreciate it or not. Remember, these are very corny. I know they're corny. Unfortunately, math jokes are all corny. It just is the way it is. Right. So the joke is, I saw my math teacher with a piece of graph paper yesterday. She must be plotting something, because you use graph paper to plot graphs. Okay, so little Fefe is on it. So here's your brain break. I'm just going to make it bigger so that you can see where you've got double trucks and single trucks and trains and all the rest of it. We know the deal. We're going to wait for the first correct answer on the chat. And then that person will explain. Take careful note of where there are doubles, where there are two trains, two diggers, etc., etc. Otherwise, we might have a problem.
Whoa, well done, Buitu. Guys, Buitu got it. Buitu, you can raise your hand so you can explain to the whole class how you got it. Well done, Buitu. Wow, that was so fast and quick. Buitu, do you want to raise your hand so you can explain how did you get 130? Okay, Buitu, explain. So everyone, we are listening, okay? Litesh, you are also listening how we arrive to an answer, okay? So everyone else, please listen up to Buitu. And all of you who got 130, well done. But Buitu was the first person who got it. So Buitu, the stage is yours. Wow us. How did you get 130?
24 divided by 3 equals 8. So each track was 8. Eight plus 9 equals 72. And if you plus the 8, it equals 18.
Good.
Each truck, one truck was 9, so there was 2 trucks, so that means each truck was 18. If you take the answer and subtract it from 18 times 18, you got the answer for this one, which was 14. So 8 times 14 plus 18, which equals 130.
Excellent. Well done. Okay, so guys, just remember BODMAS. We have to do these multiplications first, just as Boitu said, before we can do the additions. Otherwise, we're going to get some weird answers. So those of you who got 130, very well done. Those of you that didn't, I'm hoping that we understand why it's 130. And again, as Boitu said, there's some places where we had 2 trains or 2 trucks or whatever. And so we needed to remember to double the value. Whoops, sorry. Alrighty, let's have a look at some more algebra questions. And these are a little bit more challenging because what we have here now are terms that aren't necessarily all like terms. So I'm going to do the first one with you because this is leading on from some of the questions we had earlier. We can see that in the first term, I've got a y, and in the third term, I've got a y. Now, the exponents are the same, which means that plus 2y and plus 2y are like terms. But what I need to notice is that in this middle term, I don't have a variable. This is what we call a constant. And a constant is basically a number without a variable. And now because there's no variable, it therefore cannot be a like term, because remember, like terms have to have the same variable and exponent. And so this plus 3 is now a term or a group of terms all by itself. Now, some people like to group their like terms together, which is absolutely fine. So you could write your 2y plus 2y together, and then the plus 3 at the end to show that these are like terms and that is a separate like term. That's absolutely fine. You don't have to, but you can. And now because we know which our like terms are, we can add. So we've got 2y plus 2y, which gives me a total of 4y plus the constant 3. I can't add that 3 to anything because it doesn't have a like term to be added to. And so it just sits at the end as plus 3. Okay, so guys, this is now answering the question of what happens when we have different variables or terms that aren't all like terms. We group them together, we add what we can add, and that's that. So using that, I want you to try question B for me. So look at which terms are like terms, decide which terms you can add based on whether or not they're like terms, and simplify that expression for me. You can put your answers in the chat and then I'll ask for hands in a second, but I don't want any hands just yet. And guys, what I need you to take note of is that you've got a negative 3x and a negative 2. So just take note of the signs that you have in your expression.
We can do it, guys.
Me. You got it, guys. Well done. Keep answers coming. I've only seen 2 so far. It's from Sepo and Boytu. Good, guys. Keep those answers coming. And remember, guys, you are always welcome to, in algebra, have a highlighter or a colored pen where you highlight your like terms for yourself or underline in colors your like terms for yourself. Make it look like a rainbow. You do you. But if it helps you, do it. Okay, you will not be marked down for using highlighters and stuff. I can tell you that much. So if it's an aid for you, use it. Right, anyone want to raise their hand and tell me how they did it? Okay, Sepo, tell us, especially because you were one of the first ones.
Hi, ma'am.
Hi.
Ma'am, I said 5. Since 5x and x plus negative 3x are like terms, I combined them together. I said open brackets plus. I said open brackets 5x plus x plus negative 3x. Then I closed the brackets. Then I said plus 4 plus negative 2. I got my answer as 3x plus 2.
Okay, cool. So guys, oopsie, sorry. You're welcome to write all of that. There's absolutely nothing wrong with that situation. I'm just going to take a step back and just remind you of your like terms that you have here that Sepo identified for us. So we've got our x terms that are like terms, and then we've got our constants, which are like terms. And so those are the terms I'm wanting to add together. Now, Sepo's made the choice of putting the like terms in brackets. That's fine. By all means, do that. You don't have to put it in brackets if you don't want to. You don't have to group them if you don't want to. But if you want to put the brackets in, that is cool. Like, no problems with that whatsoever. Just remember your signs that you are working with. So that's why Sepo had the plus, minus 2, etc., etc. That's fine. Then exactly as Sepo said, 5x plus x is 6x, minus 3x is 3x, and 4 minus 2 is then plus 2. And so our expression simplifies to 3x plus 2. Now remember, you do have to simplify the 4 minus 2. They are like terms. You can add and subtract constants. 4 minus 2 is 2. And so you do need to simplify that. Right, so I'm just going to make that a touch smaller in case you want to screenshot those two. And then we're going to have a look at, again, in relation to the question of what happens when we've got lots of different variables that we're working with. Take your screenshot. Whoops. Good, didn't Claire? Well done. Simta, do you have a question?
Yes, ma'am, I do have a question. Ma'am, how do we know that the 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 next to x is a minus? Because 5x plus 4 plus x isn't supposed to be a minus. I don't understand, and it's so big.
Sorry, hang on. Where would there be a minus?
Because 5x plus 4 plus x isn't supposed to be a minus 3x minus 2.
But there is a minus there. There it is. And that's what I've written here, minus 3x.
Then at the end it's minus 2 or it's negative 2.
Yes, so that is the constants that are grouped together. So I have the 4 and the negative 2 grouped together. So when I say 4 minus 2, I get the plus 2.
Okay, thank you.
So I've grouped my like terms together.
Yes, ma'am.
All right, guys, let's have a look at some more examples. So if we have a look here, let's just start with question A for now. I'll take some more hands in a second. I just want to deal with this because you guys were asking. If we have a look here, what you need to see is that you've got some terms with an x, y, and some terms with an x. Now, if you want to, you can amend your definition of like terms in that they need to have the same groups of variables. So here, 2xy and 2xy are like terms because they have the same group of variables. So we can just add a little side note here, like terms, all variables must be the same. And so when we've got an x term and an xy term, we group them separately. So here, the 2xy's are like terms, so we can group them together. And the 3x and the x are like terms, so we can group them together. So all I've done here is I've just put my like terms together in their groups, so that now when I add and subtract, I know exactly adding another 2xy. So exactly as Restabile said there on the chat, we now have 4xy. And then I've got a 3x and I'm adding another x. So that gives me 4x. So as long as you can identify your like terms, guys, you can just add or subtract. So try question B. While you're trying that, those of you with questions still, you can raise your hands and I'll help you. Kotatsu, oops, let me unmute you. What is your question? Kotatsu? There we go.
You can. Evening, ma'am.
Hi.
Evening.
Evening.
How are you, ma'am?
I'm good. How are you?
Good, thanks. Ma'am, I don't understand B.
This
Like,
B
I don't know.
over here?
No, the B that we just did.
Okay, give me 2 seconds. Guys, I'm going to come back to this. Don't worry. So what I'm going to do is I'm just going to quickly erase all of this and bring B with us. Oops. Okay, so this is the question you guys are trying. I'm answering Kotaso's question. Oh, maybe I'm not because, you know, technology and me clearly aren't friends. Why do you hate me? Ay. This is how I am in class, guys. So you can just feel sorry for my students that I have to sing things all the time. All right, so that's question B. That's the question B you're trying. If you're listening to me, grand. So Kotatsu, if we have a look here, 5x, x, and minus 3x are all like terms. And then we've got 4 and minus 2 as like terms. So if I now write them all together, I've got 5x plus 1x minus 3x. Those are all one group of like terms, plus 4 minus 2. That is my next group of like terms. So if I think about the x's, and I'm just going to draw a number line to help us here. If I think about my x's, I've got 5x, I'm starting at 5. I'm adding 1, so I get to 6x, but then from 6x, I'm taking away 3. So my final landing point is at positive 3x. Then if I think about the constants, so the 4 minus 2, I start at 4 and I subtract 2. So my final point is positive 2. So that's how I simplify my expression in order to get 3x plus 2. Does that make a bit more sense?
Yes, thank you, ma'am.
Good, good. Rela Boga, question? I hope I said that correctly.
Good afternoon, ma'am.
Hi.
My question is, when doing the calculations, are we supposed to put the brackets or there's no need at all?
You don't need to. I wouldn't, personally, I wouldn't use brackets. If you're more comfortable with brackets, that's fine, but no need to.
Okay, thank you, ma'am.
Sure. Litesh, question?
Yes, ma'am. When you're saying positive 4 and negative 2, don't you need to multiply about positive 4 multiplied by negative 2?
Okay, so remember, we spoke about the fact that plus and minus separates terms. So these are two separate things. If I wanted you to multiply it, I would put brackets in to show that there's multiplication. But they're separate terms, so you're just adding and subtracting.
Okay, ma'am.
Okay, good. Righty, guys. Anyone want to raise a hand to help me out and tell me what they got for question B? Nice. Aluta, help me with B here.
Okay. Morning, you.
Morning, it's fine. We'll go with morning.
Okay. So I said 15y plus negative 7 plus negative 7y.
Mm-hmm.
It's going to be 5. It's going to be 8y. I think it's 8 or 5. It's going to be 8y.
8y, yeah.
Then I said 7x minus 2x. It's going to be 5x. So our answer is going to be 8y plus 5x.
Perfect. Well done. Okay, so guys, that's exactly it. So Aluta's grouped the like terms perfectly. So our like terms here are the 15y and the minus 7y. So you can see I've put them all in one group. Clearly my highlighting skills are like my English skills tonight. Then I've grouped my next set of terms, which is the 7x and the minus 2x. And you can see I've put it in a group there. And then I've added and subtracted. Now, the only thing I'm going to say is, and it's fine if you've written 8y plus 5x for now, we like to try and put our terms in alphabetical order. So because x does come first in the alphabet, we would write 5x plus 8y. But honestly, both are perfectly fine, especially at this level. We've just started this stuff. I'm more just saying it as it's going to become more important. So try put in alphabetical order if you can, but it's not the end of the world if you left it as 8y plus 5x. How do you spell alphabetical? Alphabet. Ooh. There we go. Right, so not the end of the world if you said 8y plus 5x. 100% fine. But we do try and put it in alphabetical order. Alrighty, I'm going to stop there in case anyone, well, stop there. I want to wait here in case anyone wants to take a screenshot, and then we're going to try one more before you get your quiz link. Okay, so screenshots, guys. Let's just do that so you get everything. Righto. Last one. Right. I'm just going to help a little bit here in that. Remember we said right at the beginning of these examples, we made a very clear statement that all variables are the same. I didn't say that the variables have to be in the same order. You just have to have the same group of variables. So x, y is a like term to yx. The variables are the same. Just because they're in the different order doesn't mean that they're different. You have an x, you have an x, you have a y, you have a y. We're fine with that. So bear that in mind when you are doing question C. So I'm just going to do that so that you can see that. Have a try of question C there for me. So you've got 6ABC plus 3CBA minus 2BCA plus 4C plus 2A. This is a harder one. We're ending on a nice challenge here, but you guys can do it. If you've been listening, you can do this one. So have a think, have a try, put your answers in the chat. I'm going to give you a minute or two, and then we'll go through it. Remember, like I say, the order of your variables doesn't matter. As long as they all have the same variable, we're happy they can be like terms. While you guys are doing that, I'll show you a fun. I don't know if you're going to be able to see her. I don't know how to angle my camera. I'm not like very smart. I don't know if you can see my cat just sitting on the wall.
No, I actually can't see anything.
No, I realize she's probably way too far away. Guys, nice. I'm seeing some awesome answers here. You are so on it tonight. Well done. Okay, I'm going to give everyone another minute or so. Just give everyone a chance to try. Well done, grade 8. Amazing stuff. Right, would anyone like to raise their hand to help me out here for this question? Blentley, help me with this last one, C.
Good evening, ma'am.
Evening.
Ma'am, yeah, I said 6ABC plus 3CBA minus 2BCA, which is equals to 7ABC, ma'am.
Good.
And then I said plus 4C plus 2A.
And why don't we add the 4C and the 2A?
Because the variables are different, ma'am.
Excellent, well done. So guys, that's it. Because C and A are different variables, those are not like terms. I can't do anything with that. Sorry, I don't know what happened there. So they have to stay as separate terms. However, we can say that the 6ABC, the 3BCA, and the 2BCA are like terms, because even though the variables are in different orders, they all have the same variable. Now, what you need to remember is that between variables and numbers, you're actually multiplying. So this would be 6 times A times B times C. And we know that the order in which we multiply numbers doesn't matter. 1 times 2 times 3 is 6. 2 times 3 times 1 is still 6. 1 times 3 times 2 is still 6, etc., etc. So order when we're multiplying doesn't matter. And that's why I'm saying it doesn't matter if the letters are jumbled, as long as they all have the same letters. Now, what I really like that Mpenentle did there is in the answer, wrote the letters in alphabetical order. So wrote A, B, C. And that's what we want to try and do. We always want our letters, when we've got multiples of them, to put it in alphabetical order. Right, so your final answer here, 7ABC plus 4C plus 2A. Very nicely done. I saw lots of you putting that in there. Guys, please don't stress. We will never forget the link. We are on it. We've got it. Don't you worry.
Definitely.
Right, but you have seen that Yolanda there has sent the link for you. So there it is. Do grab it. Aluta, do you have a question before we wrap up?
Yes, ma'am. Please can I ask, if you said 7ABC plus 2A plus 4C, is it correct?
Absolutely fine. Well done.